Hi, so Basil here with another VibeCode Delicious live stream. So I just had a bit of an interesting problem where I started the live stream and noticed that the microphone input was not working. And I actually have multiple microphone inputs, and I used an LLM to solve the problem, and it did it relatively efficiently. So I'm going to cover that. And then after that, I'm going to give a brief description of how LLM coding agents work, about what context is, what tokens are, and what auto-compaction is. And then I'm going to talk about the Context Bonsai feature that we've been working on through this series of live streams. Um, so first, let's go over this issue that happened with the microphone. So I started the stream and I'm using software called OBS. It stands for Open Broadcasting System. And within OBS, you can select various kinds of input sources, and some of those input sources are audio input sources. So I have a microphone input source, but I also have another special input source called jack input for this microphone. Jack is a Linux system for audio processing and tying various sources and sinks of signals to each other. So I can pipe audio from various devices to other various devices, or from media files to other media files, or media files to devices, all kinds of combinations. And in the middle of these processing chains, you can add special software that will process the audio for you. So I have it running through something that does some audio EQ stuff. And that was not working correctly. I have a script that's set up that's supposed to auto start all of this and configure it all correctly, but apparently something happened and that didn't work this time around. So actually, I can show you what it's like when I switch to the raw microphone input that doesn't have audio processing. First, here's what it sounds like when I type on the keyboard with the audio processing. Now this is what it sounds like without the audio processing. And here's what it sounds like when I type. So there's just a different set of filters on this raw microphone input. It's actually not completely raw. OBS does have various filters that you can apply to the audio, and I have set that up to try and make the keyboard less intrusive. There's some noise cancellation features, and actually something that happens is if I speak while I'm typing, then it even sounds completely different. So one of the things that's severely missing, let me switch it back. One of the things that's severely switching from the filters that OBS comes with is that there's no fine-grained EQ. It lets you adjust bass, treble, and mid, but I specifically wanted to dull the keyboard frequencies and the frequencies of S's. It was sounding really bad in the recordings with this particular microphone setup. The S's are way too loud, and when I listen, at least, it hurt my ears. So that's why I started looking for ways to add an equalizer to this mix. So that's what I had. And then on this stream, when it wasn't working, I kicked up the LLM coding agent. So we're going to talk about LLM coding agents. This is what they look like. You start it up and you can just type freeform text to it. And I explained what I'm doing. I'm using OBS to broadcast on YouTube. I've set up Jack to do some VST filtering on my microphone, and so on. Basically the things I explained to you. And then it just took a look at some things, and it discovered that the equalizer output from my filter is not connected to anything. So I was talking about Jack and how it connects sources to sinks. Here, the equalizer output from the EQ that I'm using wasn't connected to the input that I've set up in OBS. So it started fixing it up. Then I interrupted it and said something. I interrupted it because I wanted to give it the extra bit of information that I had this automatic system that is supposed to start everything up and make sure everything's connected. Because I didn't want it to redo the same thing or to do something that conflicts with it. So I wanted to make sure whatever solution it came up with, it works with that auto start system. So it figured it out and it fixed it. And as soon as it fixed it, I saw the little volume meter in OBS started registering that it's receiving signals from the correct source. So that's what happened there, and that's sort of how LLMs look. You type text to it, and then the LLM model responds. And not only does it respond with words like, let's diagnose the jack chain, I'll check a few things in parallel, it also can do something called tool calls, where it sends back a specially formatted message that's not just text like this, but it's a structured message that lets it execute commands on my host computer. So here are some of the tool calls that it did. Bash tool calls here. And the way that LLMs operate are pretty simple. They take a set of text, or a bunch of text information, text like this, and they will continue that text. They will predict what should follow in that text. So it's set up so that when it predicts what text should follow, it's predicting it as a conversation. It's set to expect that the text it's trying to predict is a conversation. So it will predict what happens next in a conversation. And these LLMs have been trained not only to have a conversation, but also to have particular personas and to follow certain kinds of rules. And they're also trained how to do these tool calls. Now, the final bit of information is how these conversation interactions happen. So I gave it this initial text that was sent to the LLM. The LLM continued that conversation by saying this, and then by sending these structured messages for the tool calls. And then this local tool on my computer that I'm interacting with is displaying this conversation in the format we see here, but it's also actually executing the tools that are given to it by the LLM. The LLM is just a message that has text in it, especially structured text. But then that text is structured and formatted in such a way that this tool can read it in an automated way, and it understands that this is a tool call, and here's how I execute code to complete this tool call. So it's executing code based on the text that was sent from the LLM. And the tool itself will execute the code and also produce a new message that is the result of whatever code was executed. So you run a program, and that program runs and generates text. Well, this tool takes that text and inserts it into a message. So this coding agent tool would have executed this and put a message in there for the result, and executed this and put a message in for the result, and same one for this. And then after all of that, it would send the entire conversation back to the LLM, the entire one, all the way starting from back here. So the LLM gets this full conversation that starts with this, it has its response, it has its tool call commands, and the responses from the tool calls. And it sees that entire conversation, and then from that point, it will continue the conversation after that. So the way it continues the conversation is it sends this additional text as messages, and it also sent a tool call along with that text. So the same thing happens again. This local tool will actually execute code on my computer based on that text that was sent. It will then take the output of that, add it to the message, so the message grows even longer, sends the full message to the LLM. The LLM adds its own response, which is longer, and sends it back. Additional tool calls were sent back, and the results of this search tool call was set to the LLM, so it grew again and set to the LLM. The LLM said all of this stuff. I found it, la la la, here's things to fix. So the conversation again grew, and the LLM sends the full conversation back to us. And more tool calls are happening. So this conversation is just growing and growing and growing and growing. And one of the limitations with LLMs is that there's a maximum limit to how large this conversation can get before it can no longer operate. Once it gets to a certain point, it can simply no longer produce continuations of the conversation. It can no longer predict what happens next. And the measurement, the atomic units that are causing this to grow, they're measured in tokens. Tokens are parts of words. They are subwords. So it is a tiny word. That would just be one token. But connections is pretty big. It probably broke it up into a few tokens that might have been this TIONS ending. Maybe this necked part is another token, and this con part is another token. And it's interesting why they do that, because these subword pieces have semantic meaning. But it's broken up into subtokens, and the LLMs have a maximum number of tokens that they are able to process. And once you move beyond that, they simply don't function. So another part of what this coding agent tool does is once the conversation grows and approaches that limit, before it reaches the actual limit, it will do a special operation called auto-compaction, where it generates a new conversation for the LLM, and that conversation includes everything here, the entire previous conversation, but it prefixes it with something that says, please produce a summary of the following conversation. So it says, please produce a summary, then it gives it the full conversation, and this entire thing is sent to the LLM, and the LLM continues that by emitting a summary. And that summary comes back, and then the tool processes that entire conversation and pulls the summary part out of it. And from that point forward in the conversation, if the conversation were to continue, then the new messages that are sent to the LLM, the conversation, isn't the full conversation. Instead, it's just the summary part and new messages that happen after that. So this whole giant conversation shrinks down into something that is a small summary, and then it starts growing again with every new message, every new tool call that's added. That's what auto-compaction is. That's a brief summary on how LLMs work and on how coding agents that use LLMs work. And that's when the Context Bonsai feature set comes in. That's what we've been working on over the last several live streams. The Context Bonsai feature set provides a way to have more fine-grained compactions. Instead of compacting the entire conversation, you can select portions of the conversation and only summarize those portions individually, separate from the rest of the conversation. And so that means instead of replacing the full conversation with one small summary, you might there's a giant conversation, and part of that conversation is no longer useful. Like there's just extra details in it that were temporarily useful for whatever task you were doing. You can just get rid of those and replace it with a smaller summary. So that one small part becomes smaller. And so the giant conversation sort of shrinks a little bit for every sort of chunk of messages you decide to summarize. So the idea is that instead of having this one giant auto-compaction event that pretty much destroys productivity, because by the time you get to filling up the entire context window, there's so much detail in there. There's a lot of nuance that affects future responses from the LLM, and that nuance is critically important to continuing whatever task you're working on. And when that gets compacted down and summarized into something very small, then the rest of the conversation that you have with the LLM kind of goes off the rails. The LLM starts not, well, it doesn't remember things that happened before because chunks of the conversation were never they're no longer sent to it. So it doesn't see, for instance, that you gave it a correction, like it took an action, um, and you said, "Oh, wait a second, that's not really what I meant for you to do. I wanted you to do this instead." And then it starts doing the thing, and then an auto compaction happens. It summarizes everything, and now that correction isn't there anymore, but other elements of the conversation might be there, and it might continue its activities and do the exact same thing you just asked it not to do because it no longer has the instruction that you put in there. It got summarized away. And that's a problem. So now, instead of asking the LLM to summarize everything, you get to summarize small portions, and the summary of those smaller sections are much more accurate and can preserve the detail in a better way. The LLM doesn't have to try to figure out of this entire conversation what are the important things to be able to continue my work. It only has to figure out in this chunk of conversations, these 50 messages or so, what do I really need to know going forward? Do I really need to know that I was debugging a program and I made 20 edits and finally the last one worked? No, it doesn't really need to know that. At least it doesn't need to know all of the details of every single edit. It might only need to know that there's an issue. We started a debugging session and we learned these, I don't know, 5 things. And in the end, here's the one thing that actually worked, and here's the changes we made. And then just knowing that, it can continue its tasks forward without any degradation, without forgetting really important details that are needed to continue its work. That's what Context Bonsai is. I'll give you a demonstration. It's pretty simple, actually. Where do I have that? Right over here. Okay, this is sort of an actual example of using the Context Bonsai feature set as it is now. It's currently built into the core of OpenCode. This first message says, I need your help demonstrating a feature I've added to OpenCode. It will involve a secret word that you should not say unless I directly ask you to. If you need to refer to it, simply call it the secret word. So the idea is here, I'm going to say a secret word, and then I'm going to ask the LLM to do that compaction of the message that has the secret word. And then after that, I said that the messages are no longer visible, only a summary is visible. So we're going to ask the LLM to try and tell us the secret word, and it's simply not going to be able to. Okay, so its response says that it understands the conditions that I've said. It's not going to say the secret word. Then I told it the secret word is gluon, and the secret word should not be mentioned in summary or index terms. So this minor compaction that happens still produces a summary, and for the purposes of this experiment, to prove that it's working or to demonstrate how it works, we don't want the secret word to be in the summary, because the way to show that it actually compacted and it can't remember things that it compacted, it's necessary for it not to keep repeating the secret word. So I've said the secret word is gluon. It says it understood. It knows what the deal is so far. And then I told it to compact any messages containing the secret word. And then the LLM does a tool call. It calls the tool compact. And it doesn't give that tool any arguments. It just calls the tool without arguments. And the results of calling that tool is that when that conversation of messages is sent to the LLM, every single message is prefixed by a message ID. So now, instead of the LLM seeing the message, just the raw messages, it sees the messages with a message ID for each one of them. And if you look here, in OpenCode, I have turned on the message IDs as part of the rendering so that you can see what the message ID is here. So here's a message ID that ends in SA0. That's the one where I said gluon. And then here's a different message ID and a different message ID. So once the LLM calls this tool call. The next conversation it sees is going to be the same conversation, but with those message IDs visible. So then it calls compact again, but this time it gives you an argument, and that argument is a range of messages. And here we can see the range of messages it selected. It is this SA0 message ID, starting from SA0, ending at message SA0. There was only one message it needed to compact, so the start and end are the same message. And when it called that tool call, the tool call itself will do that special message to the LLM that prefixes and says, please provide a summary of the following conversation. And then the conversation is whatever messages were selected. So the LLM responds back with a summary of whatever you gave it, those small range of messages that you sent. So this is the summary that came out. And fortunately for us, the summary does not include the secret word. It understood that it should only call it, quote, the secret word. And it also sends back a list of index terms. So the reason we do the summary and the index terms is that now for the rest of the conversation, instead of seeing the original set of messages, it sees the summary and index terms. So we leave breadcrumbs in there that help the LLM understand what was in that set of messages. This is, again, just a representation of the results of the tool call. Okay, and then this is my message back, and I said, without using any tools, can you tell me the secret word? And it says, I'm sorry, but I don't actually know what the secret word is. Even though I already told it the secret word is gluon up in that message SA0 here, this message is no longer visible. So what compaction does is, within OpenCode's storage layer of all of the messages, there's extra information added onto the message that says this message is archived. And then that piece that builds up the entire conversation and sends the conversation to the LLM, it just skips over those archived messages. So this is just not included in the conversation anymore. So that's why it responded here saying, I don't know what the word is. And then I said, use any means necessary to tell me what the secret word is. And it said, again, I don't actually have the secret word, only the rule for referring to it. If you share the word itself, I'll follow your instructions about when to say it. So usually the LLMs already, by this point, understand that they do have a way of getting that word back, of retrieving the hidden conversation. But this time it doesn't get it yet. So I said, really? You have no way to get the secret word? And then it thought about it and it called another tool. So it called the retrieve tool, and the argument it gave to the retrieve tool was that SA0 message ID. And the result of that tool call was the actual conversation. This time it was only one message, but it would get all of the messages that were archived or compacted the first time. So it sees that there was a user message, and the user message said this stuff. That's the exact message that was in that original message that I sent. And now that it can see this message, it knows that the secret word is gluon, so it's able to tell me the secret word is gluon. So that's what Context Bonsai does, and a little bit about why you might want to do it. Another reason why you might want to use a feature like this is sometimes information gets fed into this conversation that is incorrect. For instance, the LLM might be going through a series of tasks and it makes some assumption or it takes some action that leads it down a wrong path. Maybe it's doing debugging and it sees something and it makes an assumption about what it saw, and it thinks for certain, something that is wrong, and it continues down a path with that incorrect information as part of its knowledge. When this happens, it's without this set of features, it's a little bit difficult to get the LLM to correct its course. Sometimes you can sort of feed it more information that says, hold on a second, no, that part was wrong. When you did this, I think you made an assumption. And it may or may not correct its behavior from there. Very frequently, what will happen is it will still fall back to the old information, because as the conversation continues, here's another thing about LLMs: as the conversation grows and grows and grows, its sort of performance degrades. Not performance, well, also performance in terms of speed. Like it responds to you slower, but it also responds to you sort of with less accuracy or less capability. It sort of seems dumber, not as smart. So as the conversation grows and grows, if this incorrect information is in there at all, even if you've tried to correct it, it kind of gets confused, and it doesn't really understand anymore which one was correct and which one was wrong. It just has that information in there, and that information affects its conversation prediction and is sort of the things that it does after that. That is something called context poisoning. And when that happens, it's way more effective, instead of correcting it, to just use this feature to compact that away. And you can even have it specifically make sure that the summary that comes back no longer contains the incorrect version of that information. It can contain a corrected version of the information. Or it can say, these messages contained incorrect information that led to poor behavior. The correct information that should be taken from this is whatever information should be there. And when that happens, now when the LLM sees the conversation, it sees the good bits and not the bad bits. And another interesting thing about this Context Bonsai feature set is, unlike auto-compaction is destructive. At least current tools, they could be made so that it could retrieve information back, but current tools, there's no way for the LLM to get at the old information that caused the summary. So whatever was summarized, that entire conversation is pretty much lost, and there's no getting back to it. But with Context Bonsai, you saw this retrieve tool happen. The LLM automatically knew that the information I was asking for could be obtained if it could actually see those prior messages, and that's why it did the retrieve tool. So this is the feature we've been working on during the live stream. Specifically, I already got it working in OpenCode sometime in January. Then February, no, I got it working sometime in December. January, I worked on an entirely different project and mostly didn't work on this at all. And now I'm coming back around to this. And in order to get this working on the official OpenCode instead of on my fork of OpenCode, it needs to be much slimmer and not so deeply ingrained into OpenCode itself, because in open source projects, there's a cost to every feature you add that has to be continually supported for years and years. So the goal here is to make this feature work with as few changes to OpenCode as possible. So we're extracting all of this feature out into a plugin that can be managed as its own open source project. And then we're going to make surgical changes to OpenCode that have as few possible changes as necessary in order to support all of this functionality. Okay. Let's see. I have, right, this one. Nope. This one. Okay, so yeah, we talked about audio debugging. We talked about how LLM coding agents work in auto-compaction and the Context Bonsai plugin. Okay, so now we've gone through processes of planning what the changes needed are, or planning how to build this plugin. And then we took that plan and we had the LLM agent produce the plugin. It produced it, and then I used it, and it didn't work correctly. So I'm going to show you what was happening here. Okay, so here is what happened with the plugin. I did that same kind of thing that you just saw with the glue-on demonstration. I'm doing it again. I said, I need your help demonstrating this feature. Don't say the secret word. The secret word is neutrino. I understand. I'll avoid saying it. And then I said, compact the message that mentions the secret word. And then it attempted, it called the tool call. In the embedded in OpenCode version, this tool call is called compact, but in the plugin, I'm calling it Context Bonsai prune. We're pruning messages out. And that first call was just to turn on message IDs. It did that, and that worked, seemingly. And then it called the prune tool again with a specific message ID. That's the message ID that had the secret word in it. But this tool call failed. So it did it again, and it tried to do it again with a slightly different range. That's the message that has the secret word, and that's the message after the secret word. And this time the tool call succeeded, and it's done. So there's already one bug here that we've caught, and that's the plugin is not allowing us to prune out one message. It's requiring that these message IDs be different. But then I asked it what the secret word is, and it said it was neutrino. And it was able to tell me the secret word without doing the retrieve call, which means it's not working. It didn't actually prune the message out of the conversation. So I used an LLM agent, this one, and I had it start trying to debug the issue. And it went on long enough that it was going to trigger auto compaction. And by the way, I'm using multiple different LLM agents here. The one that I've built the feature in is called OpenCode. This one here that I'm using to develop and create this feature is not OpenCode, it's Kiro, and I'm using this because I have already paid for credits and I want to use those credits up so that they're not wasted at the end of the month. So I'm using Kiro here, and I told Kiro that this plugin didn't work, and I gave it the conversation that happened, and it understood both problems, and then I asked it to debug the issue. And it went and went and went, and it was filling up that conversation window and getting close to the point where it was going to compact. And it's not going to use my special Context Bonsai style compaction. It's going to compact the entire message back down. And if that happens during this debugging session, it's going to forget really important details about what happened, things it tried, things that worked and didn't work, and what new things it learned that might lead it down other paths. So because of that, we can't take the simple path of just letting it do it on its own. I had to give it a bit more structure on how to debug this. So this is a new topic that we've not yet covered in the live streams. Everything we've talked about so far, we've covered in previous live streams. This part is new. So I asked it before the compaction happened, I asked it to write everything it's tried and everything it learned about these issues into this document. So it created this document. And then I told it to also add instructions to the document about how to build the project and the plugin, how to test the plugin, and things like that. And I told it that it should have instructions to update this file every time it goes through another attempt at debugging. And it should say what was attempted and why it was attempted, what was the result of that attempt, and then what did you learn out of this attempt. So now that this file exists, if auto compaction happens, the information about what it did and what is still left to do to figure out what's happening is kept. So this has lots of attempts, like descriptions of things it tried, things that it's learned, and it was able to go for a while. And ultimately, in the end, the real problem is that now we covered this a little bit at the end of the previous live stream. It already looked like this was a potential problem that had to be fixed. And that's that there's code in OpenCode that plugins don't have access to. It's not exposed to a plugin. So I originally wanted it to figure out if there's a way for the plugin to do this in some way that works. And it attempted various ways to accomplish this compaction summary. So what was actually failing is it was asking the LLM for a summary, but the API call was failing, and it was saying this is a bad request. And the reason it's a bad request is because that message that was going to the LLM isn't going through the standard processing chain that OpenCode internally uses to send messages to the LLM. Instead, what is exposed to the plugin are some sort of raw, more low-level things for building messages, but not the final thing that allows it to format it for a specific LLM provider. So there are multiple LLM providers. There's OpenAI, there's Anthropic, there's Moonshot, there's a lot of these providers of models, and there are different formats needed by different providers. And OpenCode, because it works with multiple providers, has an internal system that will take your conversation and produce the format needed for a particular provider. But the tools that the plugin had doesn't have that level of tools. It has more low level sort of raw API formatting tools that it can use. But I don't want to duplicate inside of the LLM the same kind of system that already exists in OpenCode, this sort of agnostic LLM provider way of building conversations or requests to send to the LLM. I really wanted to use the same exact chain that's in OpenCode, but it's not exposed. And then as a fallback, I wanted to see if there was a way using exposed tools in a simple way, not in a way that duplicates the entire range of functionality, but there just simply isn't. So now we have a choice of figuring out something else that we can do to accomplish the overall goal of getting a summary from the LLM for these bits of the conversation, or modifying OpenCode further and exposing these internals of OpenCode that aren't currently exposed that we need to use to do this the same way that the currently working way does, the one that's embedded inside of OpenCode. And because my goal is to modify OpenCode as little as possible, I sat and thought about what other ways are there to do this. And what I came up with is we can simply use the main conversation thread. The plugins do have the ability to insert messages into the main conversation flow. So what we can do now is the plugin can just add a new message that says, please produce a summary of the part of the conversation where we talked about neutrinos as part of the normal conversation. So we had a conversation, and now the next message we send is, oh, by the way, that part where we were talking about neutrinos, can you summarize what we talked about? And we'll get a new summary, and we can also ask it for, also give me some index terms so that it's searchable. And that's how we can get a summary. So that will get us over this first hurdle of not being able to send messages directly to the LLM. Instead, we'll just be able to sort of append to the current conversation. So that's what we're going to work on next. I forgot how far I got into this process. I don't think I've done anything about that. Oh, maybe I have. Maybe I have. Let's take a look at this. Fix 2 bugs. Oh, yeah. This is just its like bug fixing journey. So yeah, we haven't done this yet. So our current conversation with the LLM so far is all about that bug diving journey, and we really don't need all of it to move on to the next plan of attack. So I'm going to clear all of this out. Okay, I'm going to take a look at our context. These are the files that are currently visible to the LLM. And okay, it does have the overall plan that we've been working on. So this file, Epic Context Bonsai plugin, is a file that it says, it's like an overall file for the entire plugin plan, and that overall file it's broken down into separate stories. So this overall file is called an epic, and within the epic are stories, and each story is like one small change needed to a part of the plugin to support this overall feature set. So there's this epic, it's already loaded into the context, so it knows what the Context Bonsai plugin is and what the feature's about generally. So now I can have a conversation about the feature without sort of reloading context because it's already there. I added it using the feature in Kiro called context add, and then I gave it a path like that, and that's why after I ran clear, even though the conversation is gone, the specifically added files that I gave it are still there. So now we're going to go through the planning process. And the planning process, the goal of it is to produce an implementation plan so that we can just tell the LLM agent, okay, everything we've discussed, here's the plan for how to do it. Go make those changes to the plugin. So we're going to do that. I'm going to have to give it information, another document that explains the way I like the plan to be developed. Let's see, it's some projects. Oh, gave it the wrong path. It's underscore. Okay. So now I've just added the document that explains how to produce this plan. Okay. So I've told it that you're going to use the information in this document to create a new plan. You're only going to create this plan. We're not going to implement it. Your goal is to create it. If right now, especially with the Claude LLM, if you say we need such and such, it's not going to sit there and talk with you about what it needs. It's just going to go and do random stuff. And when it does random stuff like that, it makes all kinds of assumptions about what you meant when you said you need a thing. And it's going to almost certainly produce something entirely incorrect. And not even just incorrect, but also incorrect and broken for other reasons. Okay, current summarization approach. The LLM generates a summary itself. During phase 2 of the prune tool, the LLM processes a summary and index terms as tool arguments. These get stored as archived metadata on the anchor message, and the transform hook renders them as placeholder text. So the summary quality is entirely dependent on what the LLM writes and its tool call arguments. There's no separate summarization step, no verification, and no programmatic extraction of the content being pruned. What's the new approach you have in mind for how summaries should be created? I don't think it did its research properly. Well, Okay. So I think it understood the whole deal incorrectly. It made its own assumptions when it took a look at a few files, unless things have gone horribly wrong and what we've created is not accurate at all. And actually, we did find two different problems. One of them was that it couldn't get a summary. The other one is it appeared to call compact, but it didn't actually do the compaction. Oh, maybe. Oh, I think maybe I did already implement the new version. Sorry, we went down that tangent. I did implement the new version that does the new kind of summarization, but then those two new bugs that happened are still there. The two new bugs were that I can't specify a single message range, and also even if it does successfully have a message range, the compact tool exits and it thinks it's successful, but it didn't actually compact the message away. And here we go. Original design story 4. The prune tool was supposed to programmatically extract messages, filter out synthetic parts, and call generate text via context.language model to produce an LLM generated summary. The LLM provided from ID to ID and reason. The plugin handled summarization internally. That was the original design. The generate text approach broke because of a cross-package boundary issue with provider options. The instructions field required by the context model's responses API never made it to the final request body. Okay. Then there's a new epic added. Caller provided summaries. That was the workaround that I just talked about. So I guess I already did develop a plan and I had to implement it. So I guess that part is done. Okay, and I think I might have, nope, that's the full problem. Okay. Now I need to explain the new thing that's happening. And I think I already did this. Do that. So what I'm doing now is I am trying to get the most recent conversation and export it so that the LLM can read what happened during that conversation. I want to make sure that's the conversation I'm expecting. That conversation should have neutrino. Yes, that has neutrino. So that's the correct conversation. I'm going to copy that to the current directory so there's no weird permissions issues. These LLM tools ask for permission when you're reading and writing files outside of the current directory. So I'm going to copy that file to here. Just there. And now okay, so I'm having it read that conversation. Right now it's reading just part of the file, the first 500 lines, in order to understand the structure of the JSON. And then it creates a Python script so that it extracts the important parts of that conversation out, because there's a lot of information in here that's just not necessary, like version, the summary thing, the timestamps. That's not really necessary for understanding what's happening. So this program is something it created to read that script more efficiently. And it does this because, again, the LLM can only process a certain amount of tokens, and beyond that, it fails. So everything that can be done to reduce the number of tokens that the LLM has to process is good. So filtering out the information that it's reading is necessary to do that. So that's why it wrote a little special script to extract only certain information out of that conversation. And this is what the output of that script does. It's a much smaller representation of what happened. And it wanted more information, so it created a slightly different script, and it's getting different information out of it. And again, slightly different, getting different information. And again, getting different information still. Now it sees the actual message IDs in the conversation, because that's important to understand what happened when it did the compaction. So now it sees two problems: single message rejected and pruned content leaks through the summary. So it understands both issues here. And it says the transform does replace message.parts with a placeholder. So what's supposed to happen is those messages that got compacted are no longer supposed to be part of the conversation. Instead, the placeholder is supposed to be there. The placeholder is the summary and the index terms that came back. It understands that it does replace parts of the output, but it creates a copy of the conversation instead of modifying the actual conversation, is what it's understanding here. Oh, no, it is understanding incorrectly. It believes that this mapping is doing the correct thing, and that the LLM won't see the messages in the mapped output. If the mapped output is what is sent to the LLM, that's true, but map usually generates a copy that is modified rather than modifying the original messages in place. So that copy might not be what's sent to the LLM. In fact, I wouldn't really expect it to be sent to the LLM due to the same problems that we were having with the plugin. It doesn't have direct access, or, well, it does have direct access to the LLMs, but not in a way that does all of the correct model agnostic formatting that's needed. What needs to happen is the normal messages should be modified in place, so that then the standard flow of OpenCode, what it does to send messages to the LLM, sees that the modified messages. But instead, it misunderstands what's happening. It says the real issue is simpler. The LLM answered neutrino because it already saw the secret word in the conversation. But that's not how LLMs work. LLMs don't really have memory. So when I said the conversation, the entire conversation is sent to the LLM every time, that is the LLM's memory. It's that when it receives a request, it sees the entire conversation. That's the vision it has. That is its memory. It knows nothing about previous times that you've sent messages to the LLM. Those are just completely separate API calls that had their own input and output, and they're done. So this is treating the LLM as though it has memory between API calls when it does not. So I'm going to have to explain that to it. Or maybe not, because now it says, wait, let me re-examine. After the prune at message 7 on the next turn, the transform hook should run and replace message 2's parts with the placeholder. So the LLM at message 10 should not see neutrino in message 2, yet it still answered it. Let me check if the plugin ID matches. The plugin ID is this, and the metadata key at the export is this. That matches. So the transform should find the archive and replace the parts. The anchor, message 2, has range end with that message ID, which is message 3. So messages 2 and 3 should be collapsed into a placeholder on message 2, with message 3 removed. But the LLM still answered neutrino. This could be because the model cached or memorized it from the reasoning trace, or it could be a genuine transform failure. Without seeing what the LLM actually received, we can't be 100% sure the transform failed, but the fact that it answered correctly is suspicious. So to summarize the two problems, single message range bug, secret word leaks after pruning. The LLM was able to recall neutrino after the prune. This is likely because the summary is too descriptive about what was pruned. It mentions that the secret word was stated and or the model retained the information from its reasoning context in earlier turns. This points to a summary, quality, or content leakage concern. The pruning didn't actually protect the sensitive content from the LLM's perspective. Do those match what you're seeing? Yes. It identifies the problems correctly, but it's making these guesses about memorizing previous API calls. But it's not saying for sure that's what happened. It's also saying there may be some other way that this could have leaked in, I think. So I'm going to say, yes, you've identified the issues correctly. Does the JSON file contain the tool output from compact? From, what's it called? Context Bonsai prune. Okay, so I'm asking it to take another look at the JSON file to see if it can see the tool output from the Context Bonsai prune operation. And it does see the output, and it says neutrino does not appear in the summary or the index terms. Whoop. It means the LLM recalled a neutrino from having seen it in earlier turns. So now it is making a wild assumption that is definitely incorrect. There are other explanations for what could have happened here. The prune replaced the original message content with a placeholder on subsequent turns, but the model had already processed the secret word in its reasoning traces for message 5 through 8. I don't believe that reasoning traces are sent to the LLM, at least not in OpenCode. So, yeah. The LLM itself doesn't remember previous reasoning traces. It won't see reasoning traces unless OpenCode itself decides to send those reasoning traces to the LLM. And I know from having developed this already in the past and experimenting with these things that the reasoning traces are not sent to the LLM. I have done that experiment of the secret word thing with models that expose the reasoning traces, and the thinking very clearly has the secret word, but the LLM did not know the secret word even though it had thought about it in the reasoning traces. Neutrino doesn't appear in any reasoning traces. Okay, well, yeah, it's not in the reasoning. Not only does the LLM not see the reasoning traces, but the conversation storage engine, like this JSON file, it does have the reasoning traces. It simply doesn't send them to the LLM. So it is still even able to look at the reasoning traces, and it sees that the reasoning traces the reasoning traces do not have the neutrino term. So even if the LLM did see the reasoning traces, neutrino isn't in there. So it's figuring this out. So the reasoning parts didn't cache it. That means when the LLM processed turn 10, it either the transform hook didn't actually replace message 2's content. Yes, that's almost certainly what the bug is. Or 2, the transform ran correctly, but the model recalled it from an earlier key value cache of a previous turn. Almost certainly not. So I've been saying it doesn't have memory. There is a slight caveat to that. LLM inference providers, not the model itself, but the infrastructure around it that the providers offer, have something called prompt caching. And that lets you take like a certain conversation and it will store sort of a key, a digest of that conversation and the output that came from the LLM. Or no. It will store like a key of the conversation and the actual contents of the application. Nope, I'm not. Oh, actually, that's an interesting subject. that is not something that I will cover on this channel, but there's a lot of interesting YouTube content out there about how prompt caching works. I don't understand it enough, and I'm not going to spend the time to understand it deeply enough to be able to re-represent it to you. Even if I did that, I would probably do it incorrectly and fail, and I don't want to do that. But I will direct you if it sounds interesting. I mean, I'm telling you it is interesting. I don't know if it sounds interesting the way I'm describing it, but there's cool stuff. The way it works is interesting, and it's worth looking into. But there is a cache that is stored on the provider side that does have previous conversations, and it can continue a conversation from that point. However, the way it works is that cache is only activated if part of your conversation exactly matches what was sent before. Because we are modifying messages within our conversation, our new message that we're sending to the LLM provider doesn't match anything we've sent before, so it's not going to take advantage of that cache. It just can't do it. Okay, so I'm going to mention this to the LLM. I'm going to find out if it knows what I'm talking about. First, I want to make sure we're using the best model possible. Claude Opus 4.6. Good. Okay. So I'm not trying to tell it how it works. I'm probing it to see if it reflects back that it intuitively understands how it works. Okay, so it says the cache is keyed on a prefix match of the input tokens. To get a cache hit, the beginning of your prompt must be identical to a previous request. That's what I just explained. The same tokens, the same order from the start. Cache matches the longest common prefix. So in practice, you structure your prompts so that the stable content, the system prompts, the conversation history, comes first, and new or changing content comes last. As long as the prefix is unchanged from a previous call, the provider can reuse the cached key value computations for that prefix and only process the new tokens at the end. Good, so it understands, and now I've sort of triggered that part of the LLM's sort of latent space, what it's thinking about. And it specifically says, if you mutate anything early in the sequence, even a single token, you invalidate the cache for everything after that point. Okay, so it understands that much. I was hoping that it would spontaneously realize, given the conversation we've had, that means its conclusions about the cache are not applicable. So rather than tell it it's not applicable, so why I'm not telling it things, instead I'm like probing it and getting it to recognize things, is because these LLM models tend to be sycophantic. They tend to say, you're absolutely right, even when you're not right. And it will continue as if what you said is correct, even if it's not correct. So I don't want to tell it, because I want to make sure it understands what's going on and that it's not it's not following a path that I'm telling it about. I want it to understand the problem sort of itself. I want it to intuit this problem rather than me telling it what's happening. So I'm going to lead it down this reasoning path rather than tell it how to think about it. So given so given the context of our conversation, do you understand why I asked about that? Yes, the transform hook mutates message two's parts, replacing the original text with a placeholder. Message two is early in the conversation. That means every token after that point in the prompt changes, which invalidates the prompt cache for the entire tail of the conversation. So the Bonsai plugin's pruning mechanism, as currently designed, destroys prompt cache hits on every turn after a prune. For a tool meant to help with long sessions approaching context limits, that's a significant performance cost or penalty. The user pays full input token on every subsequent request instead of only paying for the new tokens at the end. That's true. But it's still not getting it. It says this is probably the deeper motivation for rethinking how summaries work. Rather than mutating earlier messages in place, the approach should preserve the original message sequence untouched and append the summary or compacted representation at the end, keeping the prefix so the cache stays warm. Again, it's not quite getting there. It's not understanding what went wrong. So now I'm probing it again by asking it a question, not by telling it it's wrong or telling it how to think or telling it what I think is the correct answer. I'm asking it if it remembers the reasons it came up with about the neutrino. It suggested, one, the transform hook didn't actually replace message two's content, a bug. That's the one that I'm pretty sure is what's happening. Two, the model retained it from the key value cache of the previous turn. That's what I'm trying to get it to understand. Rather than me telling it, no, that's wrong, I want it to figure that out. And three, it leaked 3 reasoning traces. So 3 we already covered by my giving it the conversation history. And if those reasoning traces weren't in the conversation history, I could still prove to it that the reasoning traces aren't sent in OpenCode by, for one, I can give it a working OpenCode conversation where the secret word is present in the reasoning traces, but it still didn't remember it. Or two, have it dig through the OpenCode source code to see that the reasoning traces are not actually sent to the LLM. So multiple ways I could have done that, but I didn't have to because it already was able to look at the conversation and see that it had the reasoning traces in there, and those reasoning traces didn't contain neutrino. So 3, it already knows is wrong. 2 is what I'm trying to get it to understand is wrong, because then it can move forward with full consent that 1 is wrong. So why I'm doing this is because when LLM starts struggling on a path, if it decides, or if it doesn't have really strong reasons for rejecting various explanations, it can hop back and forth and say, I'm working on this, but wait, how about that? And it'll sort of switch tracks, and sort of when it starts running into difficulty solving the bug, it can say, hold on a second, what about this other reason? And it'll go down an entirely wrong path of trying to figure out the other reason, and it'll say again, oh wait, hold on, what about this other reason? So it'll distract itself and hop down different reasons the moment it comes across any sort of difficulty. So rather than just pushing the information into it and telling it it's wrong, I'm triggering its own internal latent space and understanding of what's going on. And I usually find that to be a strong way to prevent it from bouncing back and forth between these incorrect guesses. Okay, and now with the prompt caching context, option 2 is basically impossible. Okay, it figured it out, it understands on its own. So that narrows it down to option 1. The transform isn't actually working. The original text of message 2 is being sent to the LLM unmodified, despite the archived metadata being present. There's a bug in either the transform hook itself or in how the transformed messages get mapped back to the input. Great. Now we're ready to continue forward. And the LLM isn't going to be distracted, or it is much less likely to be distracted by these other paths. So now we're going to go down another bug hunting path. I want it to follow the same kind of thing I did for the other thing. Let me see. Oops, this is not the correct directory. I don't need that one. This is the one. Okay. So this file is really huge. I don't want to ask the LLM to read this file and do the same thing for the current issue, because this is a lot of context, and I don't want to consume the context of my primary working LLM session with this. What I'm going to do now is launch a new, fresh, clean LLM and have it read this file and understand the structure and process and produce a new template and set of instructions for how to do this in a more general way, not for this specific bug. Let's see, I want to copy this path and launch Kiro CLI chat. And then context add that file. Okay. The file has an example of how to track a debugging process. Okay, so I've explained that this is an example of how to track a debugging process, and that its purpose is to externalize information that an LLM learns during debugging, so that if the context is erased, it can pick up again where it left off without repeating. So it understands. And it's already asking if there's a particular scenario that I'd like to apply this to. Or am I looking to create a similar document for a different issue? Yes, I am looking to create a similar document for a different issue, but I'm really wanting to create a template and a set of instructions for how to do this. Okay, so that's going to produce this file now. Okay, now the order of that original file is not ideal because I kind of built it up in stages and asked the LLM to modify it in various ways afterwards, and there was no optimization for where things are in this file. I would really like all of the repeated tries and learnings to be at the end of the document so that just new stuff gets added to the end. And I would like the beginning to have constraints, open questions, sort of the general overview of what's happening. Okay, So now I've asked the LLM to restructure the document. Specifically, I want the trials and the learnings to be appended at the end. I want other stuff, including the constraints, at the beginning. And so, yeah, now it's produced a differently ordered document. So at the top, we have the instructions for the LLM that says read this file first, don't repeat approaches. It has a goal section to describe what needs to be fixed, the set of symptoms that we're observing, and a current sort of working let me see, that part was changed. Oh yeah, then it has the constraints of what are not acceptable solutions. So that constraints part exists because of something called reward hacking. This is the tendency for LLMs to like pass the test or complete the job and get like the sticker, you did a good job, you did it, over actually having meaningful impact. Like it wants to get the label of having completed it rather than the actual results that we were looking for. And because of that, it will sort of cheat. So if you're coding and you are developing tests that test to make sure that the code works as expected, if the LLM makes a modification and causes tests to fail, it can do a couple of things and say, oh, those tests were already failing and they're completely unrelated to what I was working on. Everything's good. Or it will break the test and fix them by either deleting the tests or skipping them or modifying it in a way that's incorrect, that matches the new behavior instead of the correct behavior. It'll do all of these sorts of things. And specifically, what happened is when I was debugging the issue where it couldn't get a summary, it decided rather than attempt to call the LLM, it will not use the LLM, and it will produce a summary by having word frequency counts and special, like, words that have that are more complex, that have more syllables, something like that. It tried to produce a mechanical summary rather than an LLM generated summary. So I added the constraints section to the document that says the summary must be produced by an LLM. So that's what the constraint section is about. Steps for how to reproduce and test the issue: set up, reproduce, verify the fix, check for regressions, and pointers to relevant code locations. Then it has the current understanding or root cause, sort of a working hypothesis, I guess. Any open questions that haven't been resolved that might help it get to its end goal. The next steps of once the LLM goes through like a loop of debugging, it tries something, it learns something, it has to decide what it should do next. And so that's where it records that. And then finally, at the end of the document, the things that have been tried, and then at the very end, additional notes. Okay, I'm satisfied with that. So now I have a journal debugging template. Debugging journal template. Oh, that's what's happening there. Quick. Now I'm going to copy this to something that I use across projects. I'm going to use this again in the future. So I'm going to copy it to my general project where I have this sorts of stuff, which I call LLM Conductor. LLM Conductor is available on GitHub. There's an account called VibeCodelicious, and then there's a bunch of repositories that I'm doing random experiments on, coding stuff. I'm trying to work with LLMs to make modifications to projects, and I'm also like generating new projects using LLMs. And this LLM Conductor is available there if you're interested. It also has the planning guidance document that I referenced a little bit earlier. And in previous streams, I've gone over the development loop that I use that has 4 roles that it uses to proceed through the set of story documents that I talked about. Remember, I said there was an epic document about the plugin, and within that epic are several stories. I have a whole system that will use those. It can actually use any kind of to-do system, but it will use those files to proceed through all of the tasks that need to complete. And it will pretty much run for hours. As long as the tasks are sufficient and well specified, then I can just point the LLM at that and tell it, you're the orchestrator now, complete all of these tasks. And it'll just go through all of the tasks and sort of make the changes and review its own changes and proceed all the way to the end. So if you're interested in that, the project is called LLM Conductor. And I'm adding this template to that. Now let's go back over to here, and I'm going to tell it to use that. And I believe that directory is symlinked into the current directory. Oh, that's not what I meant. It is not. So projects LLM Conductor to here, LLM Conductor. Okay, so now that entire LLM Conductor folder is available in this project, in this directory rather, and the benefit of that is hopefully the coding agent doesn't need to constantly ask for permissions. Although we did see a weird issue before where it didn't like symlinks. We'll see what happens. It was called this. Is this the tab where I was doing that? Yeah, this is the one where it figured out the whole issue. Okay, good. Oh, did I symlink that incorrectly? No files found, no files found. Okay, stop. Don't. Oh. There. Oh, there we go. If I show this, it will understand what I mean. Path is not a directory. Okay, so this is interesting with Kiro. It did not used to behave like this, but apparently now Kiro doesn't follow symlinks automatically. A symlink is just a way of having a shortcut. You have a file, and that file can have like shortcuts in other locations, but there's only one actual file. And this was pointing to a particular directory, and Kiro doesn't do that transparently. So it was able to figure it out because in the right here, I showed it exactly where the symlink is truly pointing to. So then it was able to actually get the file. And now it's creating its own file. Perfect. Okay, so now it has the file and it can proceed with debugging. So now I'm going to have this current agent act as an orchestrator. It's not going to do the debugging itself. It's going to launch sub-agents, and those sub-agents will take care of reading this file and understanding what's going on and proceeding through a debugging cycle. And in Kiro, when you launch a sub-agent, there's a default sub-agent that has 0 permissions. And if you want other agents that are able to look at the file system and execute tool calls, you specifically have to define that in the configuration. So I have a defined one called the smart one, which you also specify which model is used. So I specified the latest model that I trust, Opus 4.6. So I'm going to tell it to use the smart agent. I'm going to tell it to repeatedly launch smart agents to continue the debugging process. And I'm going to give it one more thing, that the agents should be told to think about all the potential paths it could take, select the most likely one to succeed, and attempt that, and record its progress. Use smart subagent to I'm also going to give it a file for how to do testing itself, so that it's able to run OpenCode and do the same kind of secret word test that I did. I already created that file as well. Let's see. Oh, maybe that file's gone now. Oh, there it is. I'm going to take a peek at this file and see if there's anything specific to the old bug we were working on, or if it's a more general thing. And if there's specific stuff in there, there's specific stuff about the one bug. So I'm going to, again, use an LLM to make that one generic. Do I still have an LLM running here? No. So Kiro CLI chat. Or maybe it's here. Nope, that's just not. Okay. Now I need the debugging one. Okay. So now I've asked it to create a generic version of that end-to-end testing file, but without the context summarization bug. It still needs to have specifics about this is Context Bonsai, a plugin for OpenCode, and here's how you launch OpenCode, and here's how you test the Context Bonsai features. But I don't want the specific things about how to get proper summaries, because that bug is already fixed, theoretically. And it looks like it did a decent job. It's got the Python script for how to read the exported conversations. It has information about exporting the conversation. It has information about how to run OpenCode and continue the previous conversation that happened. Yeah, this all looks correct. It looks like exactly what I wanted. So now I can copy this. This does not go into the LLM conductor stuff because it's not project generic. This is very specific to the OpenCode Context Bonsai plugin. Okay. So now that file is created and it is already in the correct directory. I can go back to the main one. I also want to make sure that the secret word protocol is in there. Does the file include the secret word testing protocol? Oh, actually it does. I can see that there. Well, even the original one didn't have it. So now I'm going to point it to the conversation. Actually, I need the working conversation that we had. So let's grab that. Export. Oh, no, that's not what I want. Conversation. Okay. OpenCode -- session. Oh, /session. Oh, this is per directory. So running it from this directory is incorrect. Running it from the OpenCode directory is correct. There. Well, history rep OpenCode.star export. There we go. Okay, I've not exported the actual working session yet. So I'm going to take this, and I'm not going to run export just yet. I'm going to grab the right session. Oh, let's see. Oh, I see what the problem is. There's an old path here that is no longer valid. There. Now I can look through the sessions. Demonstrating secret word handling in OpenCode may be the right one. Let me try this one first. Nope, that's too big. Not that session. This one. Oh yeah, this one's the right one. Okay, demonstrating secret word handling in OpenCode. So quit, and now I can export to Context Bonsai demo conversation.json. Cannot find module. Oh. It really doesn't need that module for, it's complaining about not finding a module for logging in with OpenCode, but it really doesn't need that model. So I'm going to choose a different model, that one, test, that works. Okay, and then, oops, ooh, I did the wrong thing. There, now I need the export. There we go. It's still trying to find the OpenAI Codex auth. I wonder if I can do this without using the Context Bonsai feature. work because I'm doing it incorrectly. So it's supposed to be export and then a session ID. So I'm not giving it a session ID. Let me just do this. Oh, is that what was going on? It doesn't understand disable auto compaction on this version. There we go. Secret word demonstration and OpenCode feature discussion. That wasn't it. All of these bird, dog, cat, elephant. That is the previous end-to-end testing that it was doing for this. Let's try this one and see if that session has the correct stuff. So the reason that I'm having some trouble here is I have multiple versions of OpenCode. The one I'm running now, just OpenCode by itself, is going to use the one that's installed on my system. That one does not have the Context Bonsai features. The one I was trying to run before that was showing an error message is the one that I've modified and added Context Bonsai features to, but it doesn't have the plugin that's needed to register with OpenAI, to log into OpenAI. So I'm using OpenAI models in OpenCode. And for some reason, the plugin for that isn't working. Oh, it's not working because of the directory I'm in. So I'm actually doing this completely wrong. I need to go to... So there's actually 3 versions. The system installed one, the one where I've embedded the Context Bonsai features in OpenCode, and then the final one that I'm basing the plugin off of. So the one that I've embedded Context Bonsai features in OpenCode is a couple months old. It's from December when I started working on the OpenCode, on the Context Bonsai project itself. The current directory I'm in is the plugin one, and I'm basing the plugin off the current version of OpenCode, the most recent commit as of when I started working on this. So multiple versions. This is the correct directory to get the right thing happening. Now I'm going to go back to this. I think that's what I want to run. Cannot find module. Oh, it still can't find the correct plugin for using OpenAI. That's interesting because it's been working all along. The demos I showed at the beginning were using OpenAI Codex Auth, that plugin, to use the LLM inference. So that's interesting. So then let's just try the installed version. And now that I'm in the correct directory, I should see the conversations that I'm expecting to see. Let's hope that this is the correct one. Oops. Okay. Glue on. Nope, secret. Is this the neutrino? This is a neutrino conversation. So I've done this a few times with the neutrino secret word. I want to, yeah, this is the one where it failed. Oh, no, it's not. This is the one where it actually had to use, no, that is a reasoning trace. Yeah, I think this is the one where it failed. Otherwise, I would have seen the neutrino secret word in a retrieve tool, and that's just not here. Unless this is the retrieve tool. I don't think it is. I think that's the original message. Oh, archived message where the secret word was stated and acknowledged. Then, here's another one. Oh, that is the actual message being archived. That's part of the tool call. And then the next one, it already knows. The secret word is neutrino. Okay, this is the wrong conversation. Okay, let's try exporting a different one. Oh yeah, the reason it has all these conversations is because it's not the right version of OpenCode. Is that what's going on here? It's the system installed version, which might have an entirely separate context store. So I think I might have to end the stream and figure out what's wrong with the OpenAI login issue so that I can actually use OpenCode, use my the version of OpenCode that has the Context Bonsai feature embedded, where I actually had the conversation, including the correct working functionality of the secret word protocol. So then once I get that protocol, I'll go back to the LLM and have it incorporate how that works, or maybe just save the raw conversation and have the document reference that conversation for here's what a working implementation should look like. And so it can combine the instructions of how to run OpenCode with the actual conversation that happened. And that way the LLM can verify its own results after it fixes the bug. So I'll take care of those steps after the stream. And then on the next stream, we'll come back and we'll find out if OpenCode was able to completely develop the bug fix and get it working, or if it doesn't, then we'll have a new bug to tackle. This has been a great session. So far, we've only had 2 debugging sessions for how I go through this part of the process. In prior streams, it was all focused around the planning process for how do you figure out how to tell the LLM to build what you need, and then how do you make plans that the LLM can follow, and then how does the development loop itself work. And then we finally, at the last stream, got to the place where we completed all of the development loop and we were able to test the output that it produced, and we found bugs. So now we're in the debugging session, and this was a pretty meaty session that went into quite a bit of depth about how LLMs work, how the coding agents work, and interesting details like the fact that there's a cache and how the cache works, and techniques for how to probe the LLM to show that it's understanding something rather than it's simply trying to satisfy you and tell you you're right about the things that you told it. All of these techniques I think are pretty useful, and I'm glad they were able to come out in one of these streams. So thanks for joining.